Hello and welcome to this virtual session of the CSIS panel. In this session, our goals are to get you familiarized with what is CSIS, the Cloud Security Industry Summit, share our top of mind as cloud providers and everything relates to hardware and firmware security. And basically, we want you all to get out of this session thinking more about hardware and firmware security as your top of mind as well. Because this is a virtual session, you get to enter your questions while this is running. So in the side chat window, you can just type questions and we'll do our best to answer either during the session or immediately after. Let's get started by introducing the members of the panel. I'll go first. I'm Yigal Edry. I'm today the VP Products at Chameleon. Prior to Chameleon, I was a PM in Microsoft working on Azure security, and that's how I find myself in CSIS. Ben?
Yeah, I'm Ben Stoltz. I'm an engineer at Google for about the past 6 years, focused primarily on security in our platforms division.
Hey, Ben. Matt?
Hi, I'm Matt King. I am currently the manager for the cloud hardware security team for Oracle Cloud Infrastructure, and I'm responsible for platform and firmware security for Oracle's IaaS Cloud.
Rob?
I'm Rob Wood, VP of Hardware and Embedded Security Services at NCC Group. We do security consulting with a lot of clients who are building secure products. Previously, I've got a lot of experience with embedded development and supply chain security in the mobile handset space.
Tobias?
Hi, my name is Tobias Langbein. I'm an enterprise security architect working at Zurich Cantonal Bank, a bank hosted in Switzerland, Zurich, Switzerland, and I'm mainly working on the security roadmap of the company.
Great. And last but not least, Roxana?
Hi, Roxana Walizadeh Mujarrad. I'm a security architect in Intel in a cloud platform security group.
Great. So let's get started. And we have a series of questions targeted at the panelists. I'll be acting as both the moderator and sometimes answering my own questions. So let's get started with you, Roxana. Can you explain to us what is CSIS and why did Intel create this forum?
Very good question. CSIS is Cloud Security Industry Summit, which Intel facilitate all the CSPs could come over to talk about their common security problem and trying to find a best solution for their problems. And just to give you guys a background why Intel actually initiate this summit was about a couple of years back, one of the top CSPs came over and asked us whether they mentioned that actually they like to share their common security problems with other CSPs, but because they are competitor, they could not do that. And they asked us to facilitate such a forum that all the CSPs could attend and share their common problems and find a best solution for it.
Good. Does Intel get value out of this forum, moderating it?
Not really.
Okay, excellent. So maybe we'll start by after we understand what the CSIS is, we'll start by asking each of you to talk a little bit about what are the main concerns and worries you have in the hardware security area, and basically what gets you motivated to be involved in this forum and contribute here. So who wants to go first?
Well, with the particular work that we're gathered to discuss today, this firmware development best practices for security, this is the need for this has risen out of experience with various vendors and internal projects where we see the same anti-patterns repeated again and again, even though we may be dealing with highly intelligent that we respect, they're developing good, valuable products. We still see falling into the same pitfalls. And so although this, I think the work that we're presenting today may not be really unique, it's meant to be general and kind of help people build products that are going to be acceptable to firms like Google prior to our first engagement. So we hope that there's a general rise in the level of quality attention to these details. That's my motivation for participating in this.
Anyone else?
Yeah, I sort of to echo everything Ben just said, which I think is 100% accurate. My involvement really started out of the fact that Oracle's cloud, launched this bare metal product. And as we've seen on some other bare metal products, there are a lot of interesting concerns with that. We have a lot of real dependencies on the integrity of particularly the firmware in the platform, and also sort of the hardware that underpins it. And coming up with, as I've spoken about in the past, sort of interesting solutions to these problems is great, but they don't scale well. They're hard to maintain. Having better primitives, built in from the beginning on products that allow us to trust like the integrity of the product on its own without having to do some of the crazy things that I've done in the past in order to make this work, makes the whole process of like building a cloud, choosing components, everything gets easier and better and more standardized. And at the end of the day, better for the end consumer, because they're able to then see all of that instead of having to rely on the fact that maybe I've just done things properly.
Yeah, and to add to that, and to echo what Ben said as well, NCC Group, we don't build products, but we work with a lot of OEMs who do, and we find a lot of the same issues over and over again as well. And what we're finding is that there's an increasing drive for outsourcing to chip vendors and whatnot who provide a significant amount of the firmware stack. And the quality varies quite widely between vendors. And so one thing that we're hoping to get out of this is to see that quality bar rise across the space, so that we can stop finding those same issues over and over again. And part of that is to make sure that everyone is singing from the same song sheet, making sure that everyone has a common view of the threat model. When you're putting a part out into the market, it's going to be used into products, and you assume that physical attacks aren't part of the threat model, but then it ends up getting deployed in a server, as part of a CDN network that is, physical threats are a concern. That discrepancy can often lead to serious problems.
Yeah. I can talk about myself. So I joined this group when I was still working for Microsoft, and I don't represent Microsoft today, but I can say that there has been like serious concerns about exactly what you've been talking about, that the hardware and firmware space is not secure enough. We've been seeing a lot of issues in the firmware when we try to dive deep and do the analysis for the security posture it gives us. And there were two motivations, right? One was really to be able to speak with the industry, who is usually our competitors, but to speak freely about how we fix that, because that's the thing we all share. We all want to be in a place where the security bar goes up and that we can trust the hardware. And the second, it's a way to influence both the industry and Intel. So I thought it's very useful. I still work in the hardware security space in Chameleon, so obviously I have the same, still very motivated to keep raising the bar here. So it just continued, and I continued through, even though I transitioned companies. Tobias, Roxana, do you want to say something here?
Yeah, I also joined the forum at the time where I was working in a cloud provider in Switzerland, basically. And the reason why we joined initially and why I still stuck on for the most part is basically to drive that level of exchange that you've mentioned, and also the level of alignment that we've seen over the time, and that we will also see throughout the presentation with respect to what was worked on. Because what we realized, I believe, is that problems or challenges that are seen throughout the industry with respect to hardware and firmware security are seen by every single participant of this forum, basically, and to drive that alignment with respect to coming up with best known methods and also policy as to how to address it is super useful, I believe.
Yeah. Okay. Roxana, anything to say, or shall we continue?
Very in line with what you guys are mentioning anyway. Hardware and firmware supply chain is the security of these ones are very, I mean, Intel take these ones very seriously because we are big part of this. I mean, the whole ecosystem.
Cool. So I get to talk a little bit about what we already delivered, and really the goal here is to ensure the audience is aware of that. I'll start by saying within CSIS, we have several work groups. All of us have been actively involved in the supply chain work group. So we look at the lower level hardware, firmware, supply chain things. There are other work groups dealing with other shared pains of the CSPs that are not related to hardware. So we thought this is less suitable for this forum here. So I wanted to just talk a little bit about what we already delivered and also the rationale behind them. So if we look at the firmware security space, there are like two things we've been flipping between. One is the whole question of firmware integrity. Like, how do you know that you are booting the right firmware and that you're loading properly signed firmware, and basically that you're running the code you wanted to run at the firmware level. And Nist came up a couple of, like, I think it was last year, maybe the year before, with a good draft around firmware resiliency called the Special Publication 800-193. And it talks about how to gain trust in the firmware that you're running, but it was very generic. It was aimed at like any kind of computing device. And we as cloud providers thought that it's worth doing some kind of an interpretation of what do cloud providers care about within this Nist standard. So the first deliverable we had, which is online on our website, is the position paper towards the Nist draft. And you should read it and look at it as here is the consensus view of all of the major cloud providers. They're all participating here in CSIS. The consensus view of how to interpret the standard when it comes to cloud. What are the special focuses that we care more about and that are suitable for these large-scale environments of data centers? So that was one. It was basically a response to the Nist standard, giving an interpretation from cloud providers. The second main threat that that we usually worry about is, okay, you have integrity, but if the code is not well written and well developed and well maintained, then even though you have integrity, you still have bugs, and if you have bugs, they could be exploitable. And we've seen a lot of common mistakes happening in firmware that we've been working on and reviewing. And we decided to go out and publish a best practices paper of how to write secure firmware in a better way. What are the best practices we see, and how they address common mistakes we actually see happening in the market. So that document ended up being kind of like a checklist. If you are a firmware developer, you should really take a look at that and follow the checklist. Some of it may not be directly applicable to you, but most of it should be. And we also contributed that to OCP, and recently even made it into a working Markdown version on the OCP GitHub. So you can not just follow the checklist, but you can also even start contributing to it, add your own suggestion for best practices. We will keep maintaining that and address comments. And you can even fork that if you need some specialized custom version for your own internal development. So I highly encourage you, the audience, to take a look at that and use it. And then it's kind of like the collective knowledge of people who are experts in the field to give you some advice on what to improve. And it's not a it's not a list of everything you can do. It's really focused on the things we've seen happening badly. So it should help you focus on the things that matter. So those are things that exist today out there on the like one of them is on our CSIS website. One is an OCP deliverable that you can all use. And I encourage you to also not just use it, but contribute and help evolve it to a better place. Any comments on these two deliverables from the panelists? Something you want to say that I didn't? No? Okay. So now that we understand what is CSIS and what are we doing and what have we released already, let's talk a little bit about what's happening in your companies and what are you actually doing to deal with those firmware and supply chain risks. Who wants to get started?
I can certainly talk about the public things that Google's doing. The two efforts that I think are most significant are, of course, the Untitled Chapter, which aims to take the system root of trust and make that open as far as the RTL firmware that is in the implementation. There's the other part would be Linux boot for system firmware. The OpenTitan for things like this, for roots of trust, for BMCs, operating systems, system firmware, these are all very complex pieces of code. Some of them execute primarily in the very early stages of boot. They're implemented by a small team of people for a short time. And this is a kind of recipe for sort of disasters that we see. A lot of complexities put in the hands of a small group of people who are not reusing code. It's Open aims to address that. And then the firmware issue, this is another case where we've got a very large body of code. I don't know if people realize that UEFI has as many lines of code as any decent operating system, the kernel, and the network stack, and so on. And it's not, you can eliminate all that complexity, but you can a source that has more eyes on it and one quality. There's a couple of important things that I think Google's doing.
Yeah. Anyone else?
So NCC Group doesn't make products, but like I said earlier, a lot of our customers do. And one thing that we're seeing them do more of is due diligence in their supply chains when they're inheriting some IP block or some firmware modules from a third party. We're seeing a lot more work where they're asking us to do an assessment of that. And you know, we've done that after they've acquired it, sometimes before, it's part of the like M&As or procurement process. But we're finding that they're doing a lot more of that work, and it just shows that a lot of these OEMs are starting to take the supply chain stuff seriously.
Matt, do you want to talk about Oracle?
Yeah, and I think, you know, similar to Ben's statements, one of the reasons this got started is, you know, as a process of doing some of the due diligence Rob described, you know, having done that for a while, have run into a lot of consistent problems, right? I don't know that I've dealt with any vendor that had every problem on the list that we put together, but I don't think anything on there was a one-off issue, right? Like those are problems that we've seen come up again and again across multiple different vendors, sort of independently reconstructing the same issues. And so like a big part of the genesis for this best practices document was just sort of to, you know, get a common baseline out there of, you know, these are known issues. Lots of people have these problems. Here's what you should be doing instead, or here's what you should be doing as part of your process to avoid a bunch of these common issues, right? Because sort of no matter what else we throw on top of things, if the firmware's got issues in it, it's got bugs, it's got exploitable vulnerabilities during runtime, there's very little we can do as far as, you know, integrity or recovery or other mechanisms that stop runtime attacks in just badly written code, right? If there's a lot of vulnerabilities scattered throughout the implementation, it's going to be real hard to keep the system running that firmware protected while it's running. And so I know I mentioned earlier, you know, at Oracle, we've gone to a lot of effort to recover systems, especially for bare metal instances between customers, to make sure that, you know, every customer gets a system that's got, you know, known original firmware on it. But that only is a point in time solution, right? If we want to make sure that those systems, while the customers using them aren't getting exploited, don't have backdoors, everything else, we do have to make sure that the firmware running on those platforms does, you know, have integrity, can defend itself, is reliable. And so making sure that there's, you know, consistent expectations about how vendors are implementing the firmware, you know, what expectations are, how are they doing the signing? Because if your integrity mechanism depends on the firmware signing, right, that breaks down real quick when that isn't done right. And so that was sort of, for me, the genesis of this was, I was at the point where I didn't want to keep explaining the same, you know, 5 to 10 things over and over every time I went into a discussion with a vendor about their product. We needed to make sure there was, you know, consistent, and clearly I'm not the only one who's run into this problem. And so we wanted to make sure there were consistent expectations about, you know, this is really sort of the minimum of how you should be doing it.
Yeah.
I just want to, so one of the kindest that I can put this for most off-the-shelf products, or most vendors in general, is that they're often developed with a different threat model than we have as a cloud service provider, as well as an operational model where we're expensive to just as many times as they're designed to be touched. You know, we can't reboot and wait and then hit delete or F2 and then manipulate BIOS. I think that's pretty obvious to everybody, but there are a lot of other things that we can't do as well. I was impressed by the lengths that were gone to wipe and reprogram a machine. It's not pretty, but it's very effective, and it obviates a lot of the threat model differences that the vendor has and the service provider in that case.
Yeah, I can talk a little bit about both Microsoft and Chameleon. So, like at Microsoft, I basically dealt with the everything I've been doing in CSIS was mirroring my day job in Microsoft. So it was about first of all, I think everyone knows about Project Cerberus that Microsoft developed, which is all focused around firmware integrity and ensuring boot integrity, very similar to Titan, right? So making sure we're running the right firmware. And as we were doing that, we also realized we see a lot of, we need to do a deep firmware reviews and start looking at the code. So a lot of the best practices that went into the CSIS doc were basically a mirror of what we've been seeing at Microsoft and driving reviews internally, both for firmware that we are internally developing following the SDL, but also for firmware we've seen from third parties. And then there was a big effort around supply chain compliance, basically trying to take those practices and make them into a compliance requirement, so that any vendor that wants to work with Microsoft has to comply with these set of rules and show that they are actually improving their firmware development practices. So again, it's all meant to be something that raises the bar of the industry, which helps Microsoft get to a better point in trusting the Azure hardware, right? If I move to my Chameleon role now, so we're basically still in the space, and we are looking at this and saying, hey, Microsoft has developed their own chip, and Google has developed their own chip, and every vendor has their own proprietary solution. There needs to be something that's available to the industry as a whole. So we're developing a hardware root of trust chip that takes the learnings from all of these initiatives and basically makes it available to anyone. And we're OCP members, so we expect this to be something that the OCP community will embrace. We're working closely with the OCP security work group around speccing how attestation for peripherals should be done, and we plan to implement that on our chip and support attestation of peripherals and not just a platform. But we're also tackling one more thing, which is really where our special sauce is. We're tackling the problem of runtime vulnerabilities. So after you have been verifying the boot and making sure that the boot has integrity, and even assuming you follow all of the best practices, the software will always have bugs. And we think that hardware can play a role in preventing those bugs from being exploitable, and basically make the hardware not just active during boot, but actively protecting the system afterwards at runtime. So we're trying to push it to the next level. And if someone wants to talk to me about Chameleon later, I can do that. This is not the purpose of this talk. Yeah, so that was the Chameleon perspective. Maybe we should move on to the next question, because we have one targeted at Rob. So we talked about cloud providers a lot, but Rob, you're actually a special case here, and there is a fun story of how you actually found yourself in CSIS, because we were opening it up to the community and discovered you. But also I was wondering, as a pen test company, like as a consulting firm, you probably see a lot of interesting security stories, firmware security stories in the wild. So I was wondering if you can share a few of them with us.
Yeah, we see a lot of people deploying servers that are just off the shelf, and they contain, all of the common vulnerabilities. They're meant for a very wide audience, so they'll have things like dip switches that'll turn off the security right on the board and things like that. Those are less interesting. One more interesting problem that we see with fair regularity is kind of a variation of the confused deputy problem. I've seen it a handful of times, and so I assume it's very common. So in this case, we have like some user space code running on the host. It'll ask some firmware in a particular IP block to perform a privileged operation on its behalf. The firmware running on that IP, it understands that it's running in a separate, more privileged security domain from the requester, and so it'll do what it can to protect itself from malicious requests. However, the firmware, it assumes that all of the code on the host is equal, and it doesn't distinguish between code on the host that's running in user mode versus kernel versus SMM or hypervisor. And so it allows the request from the user mode to access memory on the host across the board. And so what ends up happening in this case, and we've seen it a few times, like I said, is user mode code can essentially attack the hypervisor by asking an IP block firmware to do something on its behalf. And this really stems from a failure in threat modeling. Whoever wrote the code on the IP block didn't understand all of the use cases of the surrounding system in which it'd be integrated.
Interesting. Okay. Another special angle here is Tobias. So you've been flying over to Redmond every several months for the meetings from Europe. And I was wondering if you can share some perspective about first of all, from being an enterprise versus a cloud provider. And also, do you see Europe different in that regards from what we see in the US?
I mean, there are two different perspectives. Generally speaking, I'd say from a European perspective, there are a lot of companies that are naturally consuming cloud today, and we, from that perspective, have to be super careful and super diligent in doing our due diligence and really looking closely as to what is happening, especially, for example, in the firmware space, which is one of the major components, so to say, that is paying into the security stance per se, so to say, of the CSPs that we are using in the end. This is one angle. From that, I think Europe has one perspective. I think this is shared globally to some extent. But what is really on the top of my mind, I have to say, is that especially over the last couple of years, we see an increase in compromise, so to say, of various companies in the supply chain. And as such, we are very diligent and paying very close attention, so to say, to that supply chain aspect, and be it in firmware, for example, or be it in other aspects. Because at the end of the day, what we are really realizing is there are so many different measures that we are taking, especially in a heavily and very regulated industry, so to speak. And you know, you have your IDS in place, you have your WAF in place, and you can do the complete alphabet. And at the end of the day, there has been this area of firmware security that I think over time, and especially over the time frame that I've mentioned, has grown in significance quite a lot and has risen top of mind, so to say, as well. And for all of these aspects that I'm mentioning now, we are paying very close attention to that, especially when considering taking these aspects into our supply chain and relying on it for regulated workload.
Do you control your own hardware, or do you rely on a cloud provider to provide you the hardware?
It's actually both in our case. So on the one hand side, we have a significant footprint, so to say, and for the most part, these days still with respect to hardware in our own data center that naturally we have to pay very close attention to. And at the same time, there is this ever-growing footprint of cloud services, be it in SaaS, PaaS, or IaaS, that is growing in significance at the same time as well, right?
Yeah. Like I'm curious how you influence the cloud providers when you don't own the hardware, when you run on their hardware. Do you actually have any influence there?
Very, very true. I think forums such as this, at the end of the day, is where you can have this very vital exchange, right? And with respect to the things that you're seeing, with respect to the things that others are seeing, and to be able to contribute there and to collaborate there is of highest value, so to say, with respect to your question.
Yeah. Okay. So Roxana, Intel owns a lot of the servers in the world, I guess. And this is a common industry problem. Can you talk about what Intel is actually doing to address these threats that we've been discussing here?
Very similar to all CSPs, firmware resiliency is one of the concerns for Intel. And we are trying to be a compliance with a Nist standard similar to you guys. We are having our own firmware resiliency product similar to Cerberus and Titan, which it's called PFR. But that's one part of the equation. But at the same time, supply chain is Intel takes supply chain responsibility very serious. Just give you guys a perspective. We have, over 350 suppliers represent 60% of our spending. And we initiate a program that all of these suppliers to be transparent and compliances and accountable to what they are providing to us. And this actually reduces the risk, not for us, but for our customers, and improve the quality of our performance.
Yeah. I've heard about the supply chain initiative in CSIS discussion, so I think that's a great move. Thank you. So Ben, within the supply chain work group, we've been talking about the previous deliverables, and we've been once we released the best practices for firmware security, we've started talking about what's next for us. So can you talk a little bit about what are we going to do next, and how can the audience help us or use it?
Yeah. Well, with regards to the work that we've released most recently, I'd like to reinforce that, I think Google and a lot of other cloud service providers, probably all of them, would like to be buying more off-the-shelf hardware. And the problem is this disparity between what our threat model is, the various developed under. It can often take us as much effort to integrate a piece of off-the-shelf equipment into our data center as if we built it ourselves from scratch. So in a way, this is part of a guide to sell to cloud service provider. Please make things we are able to use. As far as work going forward, there is a trend in the industry to great things like Titan and Cerberus and Nitro and Apple's T2, TCPM and such. A lot of these and Chameleon products. A lot of effort on making these complex systems that can be created into not just system but peripherals and other subsystems. And there's a general problem with that. It's well intended. It'll be the right answer in a lot of cases, but treating security problems, complexity, you can fall into the same trap, which motivated this paper. Small teams, pressure, helping, our short time. One of the efforts that I'm encouraged about is the Open Compute Project's OpenBMC, and a lot of things are being done right. BMC has a poor reputation historically. If you look at Dan Farmer's writing, 2013 or more recent investigations by groups such as Rapid and probably NCC Group. I don't know if they've paid attention to BMCs. You can see a lot of justification for poor reputation for BMCs. And I think the Open Compute Project's OpenBMC is doing the right thing in making a trustworthy implementation of that. And that's laudable. There's a hardware effort. DCSCM introduced at OCP 2019 that aims to standardize a modular D. That's important. And one of the reasons that's important for companies such as Google is that it holds the promise that we might someday be able to state a BMC is implementing security policies and data center workflows that we need, automated repairs, audit, enforcement of security policies. I think that there is room for improvement in that effort. Not that the direction of the data center security control module, OCP's version of BMC, should be abandoned or redirected at this point. But one of the principles of that is existing technologies to implement CSCM. And I think that if we look forward 18 months, 2 years or so, we allow ourselves to incorporate newer technologies, higher speed interconnects, for example, that would allow us to fully audit, force TCB of prior to boot, that we could have a very important advancement there. This is, certainly the work that Matt and I've done an article where they every peripheral firmware, every piece of non-volatile in the TCB of a system, they had and wipe and reprogram it in their bare metals. And I think that's where we need to get to. However, the interconnects for, checking to see if your NIC has the right firmware and your storage controller is the right firmware and every disk drive in the system has the right firmware and your CPLDs are programmed properly, FPGAs are programmed properly. The amount of time to do that and the way the system is connected makes that effort prohibitive. Time budget most owner operators have for their data center solutions. So I think that there are some important improvements we can do, and that's not something that's settled. I think that's a discussion that we need to have, but is well worth having.
Yeah. So I think, like, if you mentioned that VMC has some issues, I think if you're in the firmware security space, and you don't know about the BMC issues, you've probably have been living under a rock or something. And I'm totally with you that the BMC security, both from the firmware perspective as well as from the ability to trust the hardware, make it easier on cloud providers to buy BMC, to use BMCs and be able to rely on them to be trustworthy is really important. And so we've kind of like titled tentatively the next deliverable to be called like a case for a trustworthy BMC. And I think within the community here with OCP, we encourage you to, if you're working on the BMC space, come and join hands with us and let's understand together what needs to get done, right? That's really what we want to achieve here.
Yeah.
Yeah.
And it's not that people aren't already working on trustworthy BMCs. I think what the Open BMC effort is, but I think looking what we could do, changing some of the assumption project in a little bit longer time scale. I think that's worth discussing it right now.
Yeah, and this is just starting, so this is a great time to join us and help us come up with the right ideas to drive the security of BMCs forward. So okay, so I think we're almost out of time, and I want to start wrapping up with a question for all of you in the panel. Like, what would you like to see happen as a result of this discussion? What do you want the audience to do, to think about?
So like sort of building off one of the things Ben just said, standards really help in this area, right? Expecting every vendor, every CSP, everybody to sort of come up with their own mechanism for firmware integrity and recovery processes leads to a mess. I can sort of personally attest to how complicated that picture gets over time, having been doing this for a few years now. It does not get simpler. It gets more and more complicated. The variations continue to expand over time. If you don't have standards, if you don't have like one consistent way where peripherals and platforms can all do this and interoperate, it will become intractable over time if we don't come up with consistent, reliable, repeatable mechanisms for doing this, and we keep doing sort of one-off solutions for everything as it comes along.
Who wants to go next? What do you want to see happening? You've spent an hour here. Probably have a good reason.
So one of the things that we find when we're looking at systems is we find the same common issues over and over again. And Ben and Matt have said this as well. And the short answer is I'd just like to see this stop. I'd like to see improvements be made. And a big part of that is pushing better security requirements upstream to the firmware vendors. We're seeing the OEMs are inheriting a vast amount of firmware from IP vendors with little control over the quality and the security. And a lot of this, is driven by an increasing demand for complexity with feature sets and whatnot. And so they tame that complexity by pushing a lot more of the work down into firmware. And a lot of that can be very opaque to the OEMs. Some of it's delivered as binary only. So, the users can push back on the OEMs, but the OEMs are kind of caught in the middle. And until all of the OEMs start pushing back on their vendors to get better firmware hygiene, we're not going to see a lot of improvements there. So this document that we put out here was kind of an attempt at pushing better requirements.
Yeah. One of the things we say in this document is fork this document. The document is not necessarily generic, and it's not going to fit a particular customer and a particular vendor exactly. We've tried to make a resource that you can use to form your own requirement documents or your own secure development practices. So please take a look and take from. Go ahead and make your own version of it, or add pull requests to improve this one.
Yeah, I'll join you on this one. I think it's really important that everyone in the audience who is doing firmware development, if there is one thing you take away from this, is go look at these best practices and ask yourselves which of these you're not doing, and then why. And you probably have some security issues as a result, or it's not applicable to you. So do that, at least do the assessment and do your due diligence. I think that's the like one thing. And the second thing is generally, if you're doing hardware development, think about security. What can you do to make the hardware more secure? What can you do to make your firmware more secure? The bar is high when it comes to cloud providers consuming your hardware. Do your best to actually get there and help cloud providers be able to freely consume your hardware instead of inventing their own, because the industry hasn't solved the problem by itself.
Yeah, I also like to say complexity is not always the answer. You can give responsibility over to some other subsystem in many cases. You have something to say in that area? You know, what are some simple or acceptable solutions that you'd be happy to buy?
Yeah. Tobias, any call to action on your side?
Actually, I couldn't agree more with what Matt said. I had to smile to some extent with respect to standardization. I think this is really where the power of OCP as a group kicks in, looking into what is going on in the security group, basically. I mean, keeping up that pace and basically pushing for that standardization and making sure that this, at the end of the day, provide some common ground for most of the companies involved. I think this is the best basis for providing more secure systems.
Good. And Roxana, any final thoughts before we wrap up?
I think what actually Matt and Tobias just pointed out, having a standardization for all these firmware resiliency solution, that would be the best thing, even for, and having us, the hardware companies, also compliances to all the standards and following the requirements you put together, that would be the best solution out of this panel.
Excellent. So I think at that point, we've basically wrapped up the panel discussion. So thank you all for joining me on this Zoom virtual Corona times session. I think that I want to leave the audience with just like one question in mind, which is, or actually two. Please leave this session and start thinking, what are you already doing to improve your firmware security stance? And if that's if the answer is nothing, then it's probably a bad idea. Pick the next one or two initiatives that you want to focus on to improve your security. And then I want to also ask you to tell us, like, what would help you move it forward? Like, is there anything missing, anything blocking you from investing more in security? Is there anything that we as a group of the supply chain work group in CSIS can do to help? Feel free to let us know what it is, because we can use that to prioritize our next areas of investment, or just like help you on specific cases that you'd need our help for. So let us know if we can help. We are here because we care a lot about this area, and we are happy to help anyone and the OCP community. And with that said, we're going to wrap up. So thanks again for attending and listening. Again, we are still here for questions. So if you haven't entered your question in the side chat, now is probably a good time to do that, and we'll do our best to answer. Thank you, everyone. Thank you.
Thank you.
Do we have our live Q&A now?
If people are still hearing us, we are happy to answer questions live as well. You can type them and we'll try to answer. We're all here, ready for some live discussion. So I think you have to type the questions and then we can answer. There have been some good questions during the session. so we've been answering as this was going on. There was an interesting question about the like what makes CSIS unique compared to OCP, DNTF, TCG. Every org is doing something in the space. So I thought this could be so obviously the fact that this is a cloud provider forum coming out from the requirement of cloud providers is unique angle here, but I was wondering if anyone from the panelists want to say something about that as well.
So Roxana, are you on the line? Can you answer the CSIS membership question?
Sure. Should I type it or should I say it?
Type it for, well, this is being recorded, so go ahead and say it.
Sure. There's no restriction, but the community and all the CSPs in the meeting needs to vote on the people who are trying to join the CSIS. Is mainly for CSPs, and if there is interest, just pass us the company, and then we bring it to our forum and ask all the members to vote on the companies whether they would like to have this company attended or not. And the part of the question whether this is the CSIS-based US, no, it's not. We could invite anybody from everywhere in the world.
I think the CSIS group, though, is happy to, we're trying to make sure that the work there doesn't overlap with OCP and encourage more new work to be taken on by OCP where it can be done in the open with any interested party. CSIS is more necessarily closed. It runs on a pretty informal basis. Ideas can come up and be discarded pretty quickly. You don't have to have a charter for every topic that comes up. So depending on the kind of work, it may or may not be appropriate for CSIS, but we'd certainly like to see more stuff done in the open in OCP.
There is a question in the Q&A box around from Richard Hanley. When it comes to verifying firmware image, do you imagine any standard protocols for propagating up the stack? Which I guess, I'm reading it as a question of whether there will be a standard way to update firmware and verify firmware. And that's something that's being started to work on within the OCP security work group. And I think both of us here are also members of that work group. So that's where I would like to see a standard coming from.
Yeah, I was just typing up an answer to that one. There's I know of a couple of efforts, both in Windows and in Linux, to come up with a standard mechanism for deploying firmware updates and having the mechanisms to update it exposed up to the operating system, which should allow easier updates. As we know, rebooting 24/7 servers to apply firmware updates is something that's a pain in the butt. So making that easy and seamless is a good design goal.
Yeah, the paper we presented here specifically mentions that firmware upgrade work and items that group deemed out of scope, and we try to address some of those. The firmware upgrade OCP work doesn't address the build environment, the provenance of tool chains, what to sign, when to sign it, what that signature means, and we address some of those things in the paper. My audio was pretty bad during this discussion. I wasn't aware of it at the time. Sorry about that.
There is a question about a standard for wiping systems at the end of life, deprovisioning. Is anyone on the panel aware of a place where this is being standardized?
I think it's done in all all cloud service providers that I've been in contact with, including Google. When you send something back for repairs, RMA, or you decommission it, or decommission and resale, often if you can't determine what that, the non-volatile state of that component, it needs to be destroyed. Some CSPs have the policy that all, especially in bare metal case, anything that's decommissioned is destroyed. Yeah, so that's very much the full life cycle of the product is of significant importance to cloud service providers.
Yeah, I'm not aware of a standard way to do it. I think it's still a proprietary solutions per every component. But I was wondering if you are aware from the standard.
I mean, it depends a little bit on the component. For some, it's certainly still sort of proprietary mechanisms. Hard drives and SSDs in particular have been improving lately. Most of them now have sanitize commands specifically in the spec that have semantics that are a lot better than some of like the older secure erase semantics, such that they really, really should be, definitively destroying data when you run those commands.
But that, there's a leap of faith there in some cases where you're trusting the manufacturer's firmware to the extent you can tolerate that, or to the extent that their implementation is transparent and trustworthy, it may affect the policy. You might still wind up destroying devices that have persistent storage.
Yeah, I mean, that depends on your level of confidence in the implementation in cases where you are depending on implementation-specific things. Obviously, I think those of us working for cloud providers are able to gain possibly more confidence in some of these things than if you're just buying off-the-shelf systems and using them.
There was another question about coming from Thierry Couton. I hope I'm reading the name right. Writing secure firmware is difficult even with very good guidance. Are there any tools to verify firmware source code that you can recommend? What are the tools you're using to security check firmware source code? I think we mentioned some of them in the best practices, right?
Yeah, we did. And the compiler itself provides a significant amount of build warnings. What we find frequently is a lot of those are ignored or turned off, which can be a problematic sign. But if you're looking for something more robust and something that can be tuned to find security issues specifically, there's a number of static analysis tools, for example, out there that are commercially available and are quite good. The companies who sell them are very good at providing the technical expertise to help tune them to your code base. There is some amount of setup required, and if it's a legacy code base, there'll be a significant amount of false positive triage that you have to go deal with first. But I've used them in the past, and they can be quite effective at finding entire classes of vulnerabilities across large code bases.
Yeah, one pattern I keep seeing repeated. We can go to the paper for as Rob says for a number of these things. But one pattern that irks me is that, for instance, firmware that's written where everything is unsigned 32-bit integer. And that may be the case when you are writing or reading from the actual hardware device. But once you cross that boundary into the main body of firmware, ideally that data should have a type that the compiler can check. Things that are enumerations should be enumerations in the compiler. Let your tools help you. In cases, I've seen firmware where everything is a UINT32. There's no differentiation in types. The compiler has no chance to help you out. Use the tools that are available, please.
And about the end-of-life scenario, I see that Elaine posted in the chat that the Open System Firmware Group is doing some work on this front, so you may want to look at there. Okay, I have to connect to my next session, which is starting in 1 minute. So Thank you all. I think we also managed to answer all of the questions that were posted here. So thanks again, and make your firmware secure. Bye-bye.
Thanks, everyone.
Thanks.